All right. Thank you everyone for joining. We'll get started in just a moment here. All right. Hi, everyone. Thank you so much for joining us today for this webinar series and Quasi's last webinar of 2025. This is the last in a series of 3 webinars hosted by the scientists at USGS about the National Water Availability Assessment. Before I hand things off to our speakers, I'm going to give a brief overview of Quasi while folks are getting settled and remind you of some upcoming deadlines. My name is Julia Masterman. My pronouns are she, her, and I am the training coordinator for Quasi. Quasi stands for the Consortium of Universities for Consortium of Universities for the Advancement of Hydrologic Science Incorporated. And we're a nonprofit funded in part by the National Science Foundation. Our mission is to empower the water community and advance science through collaboration, infrastructure, and education. Quasi sustains infrastructure to enable research and collaboration, including a data repository for water science data called HydroShare. By providing this support and infrastructure, Quasi hopes to help researchers formulate and execute their data management plans, be effective data stewards, and meet the requirements of funding agencies. Quasi also provides educational opportunities and infrastructure for student support. These include workshops, a summer institute for graduate students, webinar series, and events like this one, a virtual university, and more. Both our data infrastructure and educational opportunities are designed to enable collaboration and interdisciplinary work. A few upcoming deadlines to point you towards. Quasi hosts the Summer Institute in partnership with the University of Alabama, and applications are currently open for theme leads, so a mentor position, as well as fellows. Applications are open now, and we hope that you'll consider joining us for this program. The Summer Institute aims to engage the academic community in research to advance water prediction and flood forecasting. And we're always blown away by the work that comes out of these 7 short weeks and the impact that this program has on the students who are a part of it. So if you have any questions about this program or want to learn more, please visit our website or reach out to me directly. I'd love to chat. Thanks so much. Also, if you find yourself at AGU next week, Quasi will be there as well. Quasi will be at booth 836 in the exhibit hall, and our staff will be all over the meeting as well. If you see one of us, come say hi or come meet us in the exhibit hall. We'd love to see you. With that, I'd encourage you to join our mailing list if you are not already a part of it and connect with us on socials. This webinar is being recorded and will be posted on our YouTube channel. And if you're interested in recordings of previous webinars, you can find those on our YouTube channel as well. All right, as I mentioned, this webinar is a part of a 3-part series, and this will be our final webinar. So thank you for joining us throughout this series if you have. And with that, a few logistics. We ask that you use the Q&A functionality to submit questions to our speakers. Feel free to add questions at any time and upvote any that are especially of interest. We'll do our best to get to as many as possible at the end. And we expect that all involved with Quasi Cyber Seminars uphold the Quasi Code of Conduct and promote and maintain a professional, considerate, collaborative virtual environment. So thank you for being a part of that. And with that, I will pass the mic to our speakers. Thank you so much for joining us, and take it away.
Excellent. Thank you, Julia. All right, we'll get our slides set up, and we're just really pleased to be here. We're glad that we were able to get rescheduled. Today, we're going to talk a little bit about the new Data Companion Model Data Delivery Tool. And this is something that Shirley, Leung, and our software application development team have designed and developed. And it's to share out the National Water Availability Assessment data. And we're also joined today by Galen Gorski. So if there's questions that come up about our assessment report over the time, then he'll be available to answer questions at the end as well. I just want to acknowledge the other co-presenters of this cyber seminar series, those that talked about the report or those that talked about the data science behind all of the analyses. And again, thanks for letting us host this USGS series. We appreciate Quasi's partnership in this, and we're grateful for all of you for spending time with us today. Next slide. So as an outline of where we're going today, I'll talk a little bit about what the National Water Availability Assessment Data Companion is, or NWDC, how it's different than our existing data products, and what the model outputs are and which ones are available now. And then Shirley will get to give a website access demo of all of our tools. Next slide. So we're talking about the data and information behind the latest models that have come out from USGS. These models went into the assessment report, and the map on the slide represents the supply and use index. It's one of the interpretive variables, which is available for the whole continental US at a watershed scale. Now you can see it's continuous across the country. It doesn't have point locations for monitoring. So this isn't the National Water Dashboard that we're talking about today. It's not our gauge data. It's something else. It's something new. The NWDC is complementary to our observational data. It provides a standard water availability footprint for the continuous lower 48 to be followed by the rest of OCONUS in the near future. Next slide. So the themes included in the NWDC represent water quantity, water quality, water use, and ecosystems. And we're charged by the Secure Water Act to assess water availability across the entire nation and to deliver that information about core indicators through a variety of means, including reports, graphics, and just getting the data out. And so our new delivery system that we're talking about today will provide access to the same information that's went into the assessment reports, right now focused predominantly on quantity and use. Next slide. But if you'd like to read the report, it's available. You can get to it through the QR code. And the assessment report has a really nice executive summary. So that first summary goes over everything highlights everything that's in the report. And then chapters B, D, and F are those that parallel with the data companion right now. It's again a picture of quantity and water availability and use. Next slide. And I do want to take a moment to highlight the number of people it took to pull off this assessment. We recognize the report authors, the modelers, the science communicators, the developers, the subject matter experts, and the managers that are listed on this slide. Our developers that created this product that serves out the interpretive model results needed to interact with many of the science leads from each of the modeling teams that we were serving. And so highlighted in the orange box represents those developers that collaborated over the last 4 years to build this new open source delivery system. Next slide. So everything's live. So feel free to use the QR code to access the website and follow along during the talk. The website URL is listed too, and everything is available. You can use mobile or a desktop. It works in both places. In a nutshell, the Data Companion is a centralized website where users can go to retrieve standardized national model outputs related to water availability. And we're providing various user-friendly methods to get that data. But it's not just the data that you can find, but there's helpful information about the outputs and how you can use them. So what we're trying to do is provide published model outputs and interpretations from multiple teams and make them easy to find and access. We want to help users to extract the subsets that they want and keep the data highly consistent across all the models. Next slide. The data are standardized to hydrologic unit code 12 sized watersheds. or you'll hear us say Huck 12 watersheds. These are just small watersheds, about 80,000 across the US. And all of the data is at a monthly time step. So initially, we'll serve data for the continental US, but then we'll expand soon after to Alaska, Hawaii, and Puerto Rico. And the data is available during the time period of 1980 to 2020, depending on the model. Next slide. So these data sets are available now. Water use from the three largest categories of use: thermoelectric, public supply, and irrigation. And again, these are modeled outputs at monthly time step, which is a huge improvement from the 5-year estimates that we used to do. Now, also, I want to highlight hot off the presses in December, the water quantity data, the ensemble model outputs, and the atmospheric forcing information, and the water availability assessment outputs, like the supply and use index, those were just added last week. So you're the first scientists to learn about our recent release of these data. As USGS is also planning a webinar on January 13th to promote this availability of these data. So you're welcome to join us again if you want to hear more about them. Next slide. The data companion is planning to serve many other model outputs over the next couple years. These on the slide represent what you can expect in 2026 and 2027. There's 5 additional water use categories. The OCONUS data for Alaska, Hawaii, and Puerto Rico, and trends information for all the models from the assessment report will be available through the NWDC, as well as water quality data from a continental US Sparrow model represent nutrient estimates. So I'll wrap up here and pass over to Shirley to share about our data access tools and provide a live demo. Thanks so much.
Cool. Thanks, Jennifer. So now that you know about the data that we're serving and a little bit about the website, I'm going to give you an overview of the data access methods and also demo the website live. So we've done a lot of user research to figure out which data access tools to build. And based off of that user research, we came up with these different tools shown in this slide that work best for different types of users, as summarized here. So those shown in bold text are available now, and those shown in gray text are still undergoing development and will be available later. So data access methods that are tailored to a general public audience are our interactive data catalog and subset and download tool. Other tools for a general public audience that we'll be adding include an interactive map and watershed pages, which summarize information over a user-chosen watershed of interest. Data access methods that we have, which are more tailored towards more technical users, which are likely most of you here, include a data file directory and an API. We're also planning to create an R or Python package that wraps around our API in the future. Okay, so with that, let's get into our demo. You can use this QR code, as Jennifer already showed, or type this URL, water.usgs.gov/NWAA-data into your browser to follow along if you want to. All right, so this is what it looks like when you land on the homepage. And first, I'm just going to start with a quick walkthrough of all of the options in the drop-down menu. So starting with access data, you have the 3 data access tools that are available now: the subset and download tool, the data file directory, and the API. Then under about the data, you have a data overview page, the interactive data catalog tool, a data availability page, and an about the report page. From these different pages, you can learn more about the data and how it's organized within the website. And you can also see what all data sets are available. And then under help, we have tutorials and glossary. And finally, the usual about us and contact us pages. So before I dive into showing you all how to access the data, let's first learn a little bit about how it's organized and what all is currently available using the data overview page. So here we can see that we organize the data in the data companion in 2 sectors. So these sectors are really just categories or groupings of related models and data sets that correspond to those core indicators that Jennifer showed earlier. You can also kind of think of them as basically water topics or themes. So we have 5 sectors of data in the data companion: water use, integrated water availability, water quantity, water quality, and aquatic ecosystems. And right now we have data available in these first 3 sectors, with data in water quality and aquatic ecosystems sectors coming later. So within each sector, we have different models, and within each model, we have different variables. And each model within a each variable within a model belongs just to that one model, and each model belongs to only one sector. All of the actual data itself is at the variable level, while the models and sectors are just groupings of those variables. This architecture is important to know because you're going to see it throughout the entire website and when you start to download the data. So this data overview page tells you which sectors are available now and will be in the future. But if you want to know which specific models are coming or that are available now, then you can check out the data availability page, which lists all of that out here in this table. All right, so now that you understand how the data is organized, let's check out what variables are available to download from the interactive data catalog page. So this data catalog page will show you all of the variables that are available to download now, and it lets you search or filter down to the ones you're most interested in. It's organized by sector, then model, then variable in these 3 different columns. So say you're interested in water use and you wanted to just see what all is available in that sector. So you could filter down for that and download as much or as little of these variables as you wanted. You could also say you're interested in seeing if there's any data related to runoff. You could type in correctly. Oops. Okay, my keyboard is acting funny, but you can see that runoff is available. Oops. Sorry, this is the risk of live demos. You always have something go slightly weird or wrong. You can see there's a variable for runoff right here. And when my keyboard is working, you would normally be able to type that in to this box and filter for that. So you can also alphabetically sort any of these columns in order to help you find stuff more easily. And then once you've decided on your variables of interest, you can access data for those variables by hovering over these data access data buttons and clicking on your preferred data access method. But we know that before you do that, you probably want to be really sure that you're downloading the right variable for your science needs, and you want to understand what the variable really represents. And some of you may even want to know all the nitty-gritty details behind how it was calculated or modeled. So one thing you can do to quickly start to check all of this is look at a map of the variable and see if it's giving you what you expect. So for example, you can click any of these map icons and see that historical period mean map of the entire country for that variable. And so here, once you open this up, you can choose between a basic and a detailed version. You can download either one as a PNG if you want to include it in a presentation or report. And really the only difference between the basic and the detailed version is the amount of metadata that's contained in the image. The detailed version has more metadata, and that helps the map image stand alone more easily, and it points people back to the data companion and assessment report with links for more information. So another way to get the background info and metadata that you need about a given variable is to visit the variables information page, or info page for short, which is also linked here on the data catalog page. So let's look at the variable information page for total water availability, for example. So checking out this overview menu first, you'll see that this variable is from the National Water Availability Assessment Outputs CONUS 2025 model, which is then categorized under the Integrated Water Availability sector. And you can also see from this overview menu the units of the variable, as well as the originator and license, and finally the spatial and temporal extent and resolution information that we know people quickly want to be able to find. So at the top of the info page, you'll find quick links to help you access the data and also to cite the data. So let's check out these citations real quick. Here you have a citation list that you can use to just copy and paste. And that way you don't really have to think about it too hard and figure out what those citations would be on your own. So we first have a citation for the website itself, for the data companion. And then we have a citation for the data set. And finally, for the journal article that explains the methodology behind the data. For those who really want to know the details of the methodology behind the data, I encourage you to check out those journal articles that are linked in this section. Then going back to the top, in the main body of the info page, you'll be able to find a summary and technical explanation of what the variable represents, as well as that same map that you already saw linked on the data catalog page. You'll also find usage information, including how you can map the data, along with strengths, limitations, and sources of uncertainty associated with the data. And if you keep going, you'll come back to this citation list that we looked at earlier. So every variable in the data companion has an info page like this one with the same type of information and metadata. Each model and sector also have their own information pages. So checking out the model info page, here you can see that you can get a list of all the variables within that model and find a description of the model as a whole. And then if you go to a sector info page, you can get a definition of that sector, as well as a list of all the models within it. For now, this sector only has one model, but there will be more coming later. And all of these information pages can be accessed from the data catalog page, whether that's the sector, model, or variable info pages. All right, so getting to the more exciting part. Say you finished looking through the data catalog and you perused enough of the info pages to know exactly what you want to download and use. Now, how do you actually get the data? So one easy way to start is to use the subset and download tool, which you can access from the main menu, from the data catalog page, or from the homepage. So this tool lets you specify the model, variable or variables of interest, the spatial extent, temporal resolution, the date range, and the file formats you want in a guided step-by-step process. And once you have selected your desired options, you can download the data from this web page directly or copy the generated URL into your code. Look and feel of this page is modeled after other USGS web service URL generator pages, so it should feel somewhat familiar to you if you've used those before. Right, so let's actually try it out and look at some data together. So say I had decided that I wanted to download evapotranspiration or ET data. From exploring the data catalog, I know that that's in the water quantity sector. So maybe I'll just filter for that and just show the models under that sector. And then I know it's coming from the ensemble model. I can select all of that here, or alternatively, I could also come from the data catalog page directly. I think my keyboard works now. Yep. And I can look for that variable that I want and then go to the subset and download tool from there, such that the model and variable are pre-filled for me already. So here you have these quick links again to go to the associated model and variable info pages, just in case there's any information that you want to re-review. And we also write out the model and variable IDs here, which are really just abbreviations that we use whenever it's not so practical to write out the full names. So you'll see those throughout the website as well. All right, so next we'll select a spatial extent. So a really important note here is that no matter which spatial extent you choose from this drop-down menu, you are going to get a spatial resolution of HUC12s. So for example, if you chose like a larger spatial extent, like HUC8, you're going to get all of the HUC12s that are contained within that HUC8. And another quick note is that you can only query one spatial extent at a time. So say you wanted multiple HUC8s or HUC6s or something, you'd have to use this tool again in order to, again and again, in order to get all of those HUC6s or HUC8s that you wanted. All right, so I want to get ET data for a specific HUC12 that I have in mind. So I'm going to select HUC12, and then I'm going to go to this HUC ID finder to find that HUC ID I want, and then I'll plug it back in there. So I am interested in the HUC12 that is in the Florida Everglades and contains the Big Cypress National Preserve. So here you can see the HUC level, the HUC zoom level you're at. So right now it's 10. That means I need to zoom in more if I want to get the HUC12s. So I've done that. Now I can click where I want, copy that HUC ID, and bring it over here. All right, so now I want the monthly temporal resolution. So that's the default, and all of the model outputs we have do have a monthly temporal resolution by default. And so that's because all of the raw model outputs are monthly. And so whenever you get something that is more coarse than monthly, that's because we've kind of done additional computation for you to be able to get those other temporal resolutions. All right, and then I want to know the ET over as long of a time period as possible. So I'll get the entire historical period. And when you select entire historical period, it's going to switch the dates to the whole time period that's available for that data set, which you can see here is from October 2009 to September 2020. You can see that here as well. And then finally, I want to get the data back in JSON format. So you can see here that since I finally filled out all of the information above, I was able to generate a URL with all of those things that I specified, and I'll be able to click run to look at the results. So here's the data that you get back in JSON format. You can see that there's a metadata block first, and then that's followed by a data block. And inside the metadata block, you have information like the units of the variable, and then you also have the number of HUCs or records returned. This is just one in this case, which is what we would expect since we only put in one HUC12. And then here you have a link to the URL that was used to get this query. And then down here you have the data. And so that starts with the HUC ID, the HUC12 ID that we put in right here. And then you have this year month format for the date, and then the value, of course, for each of those months for the variable. And if you scroll down, you can see that it spans the whole time period that we asked for, all the way to September 2020. And I'll make a note here about this date format that we use. So this is what we use throughout the whole website, and we call it year month. And this is how we indicate the date throughout our whole website. So basically the format is just the year and then a dash and then the month. So be on the lookout for that, because we don't, for example, put the day in there as well. All right, so that's what the JSON looks like. And I also wanted to show you guys what CSV formatted data looks like too. So let's do one more example. Going back to the top, this time let's look at water use data. So let's get public supply withdrawals data, both from groundwater and surface water. One nice thing is that you can get data for more than one variable at a time inside one file or just from one query if those variables are all coming from the same model. So I'll choose these two variables. And then this time for spatial extent, let's look at county. So again, remember that even though you're querying a county, you're getting all the HUC-12s inside that county because the spatial resolution of the data coming back will still be HUC-12s. So for this, I will choose the county that I live in. I live in Seattle, so that's in King County. And then here, this is asking whether you want to get all the HUC-12s that just overlap or touch the county, or whether you want to get the HUC-12s that are only get the HUC-12s that are completely contained within the county or completely enveloped within the county. So I'm going to choose overlap because I want to include more of the county's area, and I also want to show you guys visually more what this actually looks like and means. So if you want to be able to visualize that, you can go to the spatial extent viewer, which is linked right here. And then you can put in any of your spatial extents of interest, but right now we'll do the county that I've been looking at. So you'll be able to see, using the spatial extent viewer, all of those HUC-12s that are part of that county that you're trying to query. And these orange ones are the ones that are completely contained or enveloped within the county, while these blue ones are the HUC-12s that are only touching or just overlapping the county. So again, I'm going to choose overlap because I want to include more HUC-12s in my data set that I'm downloading. And so if you choose overlap, it includes both these blue and these orange ones. All right, good. And then this time, let's get water year for temporal resolution. So as I mentioned before, the raw model outputs are monthly, but we have heard from a lot of users that they want yearly data. So we do provide the option of getting both water year and calendar year averages instead of just raw monthly outputs. And we just compute these from those raw monthly outputs for you guys. All right, and then let's choose a custom date range. So let's say water year 2015 to water year 2020. And finally, we'll select CSV for the output format this time. You would click download file, but I don't want to make you guys wait for that. So I have already downloaded this in advance and opened it in Excel. So let's see if I can get to that file. All right, so this is what the data looks like when you have downloaded that file. So here in this first column, you have your HUC-12 IDs. And then in the second column, you have the year, which is water year in this case. And then in this third column, you have that first variable that we wanted, represented by its variable ID and its units. And then finally, that second variable represented by its variable ID and its units in this last column. So if you scroll down, you can see that all of the HUC IDs that are overlapping King County are represented here, and that there are pretty different amounts of public supply withdrawals from both groundwater and surface water throughout those different HUCs overlapping the county. So if you wanted to quickly check which HUC ID is located where, you could, again, use that spatial extent viewer that I showed earlier. So you could, for example, if you wanted to know where this one was, you could copy paste this ID, put it into the spatial extent viewer, and that would show you where that's located. So yeah, that's how the data is formatted when you download it from the subset and download tool. So let's just go back to the website real quick. Yeah, so I do want to, again, important note, tell you guys that we do highly recommend against trying to get really large regions over long time periods from the subset and download page, tool page. So if you're trying to get, for example, HUC2s or large states, we do really highly recommend that you use the data file directory instead. And that's because it's just a lot faster and easier for you to download and also probably to wrangle for your later data analysis as well. And if you're trying to get CONUS-wide data, kind of for the full, like over the whole full spatial extent that the data exists over, you should definitely 100% be using the data file directory to get that. And really using the data file directory also on our end helps save us money because it's cheaper if you download from there versus us having to do kind of these computations for you, slicing over the areas that you need. So with that, let's take a look at how to use the data file directory now. So you can access that under access data and then going to data file directory, or again from the data catalog page as well. So this data access method is really for anybody who wants to be able to easily grab all of the data over the whole country as far back as it goes, or again, for those who want data over really large areas of the country. And we've heard from users that it can be a real hassle trying to get data over their full spatial and temporal extents by having to repeatedly call the data in an API in a for loop. And we've also heard that people sometimes feel unsure whether they have really gotten all the data when they have to use that method. So this data file directory is trying to help prevent all of that and lets you get all the data in one or at least very few files in a way where you can be sure that you aren't missing anything. So we set up the structure of this data file directory such that it follows the usual data architecture, where you have a folder for each sector containing subfolders for each for all the models, and then inside those model folders you have variable subfolders. So we hope that this logical and predictable folder structure enables you to navigate the data file directory easily, but also that it helps you write reusable code where you can download data using commands like wget and curl. So let's get data for one variable of interest together. So say I wanted to download data over the whole country for the whole time period that it exists for incremental runoff. Again, from the data catalog page, I know that I would first go into the water quantity sector folder, and then let's close this, and then into the ensemble model folder. And finally, I can go into the incremental runoff variable folder. So once I get into this variable folder, I can see all the files that are available for this variable. And let's just go through them real quick and understand what each of them are. So starting with the metadata is all of the files except for the two data files. These two CSVs are the actual data. So let's check out this describe.txt file first. So this file tells you about the spatial and temporal dimensions of the data, and also gives you a quick statistical overview of the data as well. So here we can see the mean, the median, the quantiles, and the lowest and highest 5 values of incremental runoff. And that's across all of those over 83,322 to be specific, HUC12s in CONUS from October 2009 to September 2020. Then the next thing is this histogram. And this histogram just shows you the distribution of the incremental runoff values, again, across CONUS for that entire historical period when it's available. And this is handy for just getting a quick feel for what those numbers look like and what those values might be. So then after that, this is too big. Okay, so then after that, we can see these maps right here. And these are just the same maps that you guys have seen everywhere else, but they're also stored and available here if you want to access them with curl or wget. Then finally, for metadata, we have these two README files. So these contain the exact same information as you're going to find on those variable information pages, but we know that we've heard from people that sometimes they prefer these kinds of file formats, especially when they're stored in the kind of same place as the data itself. So we have both HTML and XML formats because the HTML is, as you know, a lot more human readable, while the XML is more machine readable. So hopefully that meets all of your needs. All right, and then finally we get to looking at the actual data. So the actual data for this variable is contained in these CSV files. There's a long CSV file as well as a wide CSV file. They both contain the exact same information. They're just formatted slightly differently. And so I'm going to pull those up now in Excel just to take a quick look at how they're formatted. Again, I wanted to save you guys the wait of watching me download that. So I've already done that in advance and opened them here. So let's start with the wide formatted CSV. For the wide formatted CSV here, what we have in this first column is the year month. And so again, wanted to remind you guys that anytime you're downloading data from the data file directory, you are getting those raw model outputs. And so it will be at the monthly temporal resolution, which is what the models put out. And so, yeah, the rest of these columns are just the HUC 12 IDs covering the entirety of CONUS. And so if you keep, scrolling to the right here, you're gonna end up with those 83,000, 322 columns. Hence, that's why these CSVs are called wide, because they are very wide. So that's the wide format. Then I also wanted to show you guys the long formatted CSV. So you can see that this long formatted CSV downloaded from the data file directory has the exact same format as you would get back from the subset and download tool. So you guys have kind of already seen that. But as a reminder, in the first column, you have the HUC 12 IDs. In the second column, you have year month. And then in the third column, you have the value of the variable for each HUC. With that variable ID and then the units in the header. So scrolling on down, you'll see that HUC after HUC across CONUS is represented here. So again, that will go through those 83,322 HUCs by the time you get to the bottom of the file. And that's helps you understand why these are called long CSVs. They're very long. And one important thing that I wanted to point out that you can see here is that a lot of the HUC 12 IDs have a leading 0. And so we just want people to be aware of that, because I know I've made the mistake of accidentally dropping leading 0s when I load in data. And so you do want to be sure that you keep those, because it is important to properly identifying those HUC 12 IDs. And then back to the website. Another important thing I wanted to note is that the metadata and data for all of the variables in the data file directory are formatted and structured in exactly the same way, with all variables, for example, having both those long and wide CSV files, and they also have all of the same metadata files as well. So that we hope that that really helps you be able to reuse code. So if you use code that can analyze one variable, you can quickly plug in a different one to be able to analyze that one as well. Then the last data access method we have available that I want to tell you guys about is the API. So technically, the subset and download tool is just an interactive wrapper around the most salient and most often used parts of the API. So if the subset and download tool already meets your needs, then you really don't have to dig into the API any further. But if you want to access the API programmatically or do development against it, or you just want to know everything that it can do or everything that you can get from it that may not be included in the subset and download tool, you can check out the documentation on this web services page here. So this page has pretty detailed documentation. You'll be able to see exactly what all the options are for every single parameter. And it's also really pretty good for somebody who's pretty new to APIs. So you get an explanation of different endpoints and all that. But we have heard from people who are more experienced API users or even developers that they kind of just want to see the Swagger or VDoc documentation. So if you haven't used either of those before, Swagger provides you a quick and simple interface for exploring and testing the API, while VDoc does a pretty similar type of thing. Some people like this kind of interface better. So I did want to mention one thing that might be helpful in this documentation, longer documentation page that's new for the website as of our latest release this past week. And that is that we now have pagination for our API. So if you guys are getting really large amounts of data over those large spatial extents from the API or from the subset and download tool, you're going to get sent back multiple pages or files, and you'll have to download all of them in order to get all the data you're requesting. So if you do want to know, understand better how that works and make sure you're using it correctly, you can go to the data tab here and scroll down to data endpoint pagination. And you'll get to read about that in more detail in this section. But yeah, again, I want to take this opportunity to really emphasize that we highly recommend only using the API and the subset and download tool when you want to get smaller spatial extents and smaller chunks of data. And please to instead use the data file directory when you are getting larger regions like HUC2s or large states, and then definitely when you're getting all of CONUS. Okay, so the very last thing I wanted to show you guys on the site is the tutorials. So those are available under the help menu item and then here. And so here under action-driven use cases, we provide code snippets written in both R and Python, showing various examples of how to download and analyze our data. So let's just take a quick look at this first tutorial that shows you how to plot CONUS-wide data downloaded from the data file directory. So if you go into this page, you'll see that you can either access a notebook in Python or a notebook written in R. And you can see all the packages required in order to run this code. Then you'll get a little primer on how to construct URLs to download from the data file directory. And then finally, you get into the fun stuff where you get to see an example of how to plot the data across CONUS on a map. So for this part, we really encourage people to use the package PyNHD if you're using Python. And that's a package that's created and managed by USGS that kind of compiles all of the geospatial layers that you might need. And if you use this PyNHD package, you'll be able to download the HUC12 geospatial layer that you need to map this data really easily using just this one line of code. And you'll then see how you can join this geospatial layer to your data and finally to draw that CONUS-wide map. All right, so I think that's everything that I wanted to show you. And we're super happy to take any questions or get any feedback about any of it in the chat. I'll pass it off back to Jennifer now to give you some more important tips about mapping the data, and then she'll also give you a sneak peek of some of those other data access methods that are currently under development. Thanks.
Thanks a lot, Shirley. I hope you all feel like there's something in there that Shirley presented that is going to work for you. Like the team has been really trying to be really thoughtful and comprehensive about what they provide. Can you go to the next slide, please, Shirley? And so, like she said, I'm just going to highlight a couple things. And one, Shirley just mentioned this, but it's important to just to reiterate, if you're going to be mapping these data, there is a spatial data layer, what we call the main stems, WBD. That's the common operational data set that our modeling teams have used to ensure that everybody was working on the same geographic data set. So you can get it through the package that Shirley mentioned or within our various variable pages, there are links that are easy to find on those. So feel free to use that if you're doing mapping. Next slide. Continuing in the mapping bent, we're currently working on an interactive map that will allow you to visualize the variables that you can get from the data companion. And this should be out later in 2026. Next slide. One of the features that we're working on that'll end up being part of that mapping application is also a watershed page. And these watershed pages, you can type in your HUC ID or a zip code and explore a watershed of interest and get quick facts or statistics, or just be able to see a time series of variable of interest. And so these are something that the team is just beginning development and will be out later next year or early 2027. Thanks very much. Next slide. And then, I've seen in the chat, there's some interest in Python or R packages, and it's always been something we've been planning. The R or Python packages will help users to download data and would work similarly to the USGS data retrieval package that lets you download information directly into R or Python. We needed some of the foundational components like the API and mapping services to support these tools. So that's why this development is just coming a little bit later. Next slide. And I'll just summarize, like, these in bold are the main tools that are available now for users to download information and get information from the data companion. And those that are in gray are coming later. Next slide. So how are people using the information in the data companion? We have approximately 200 data companion users a week. Folks have told us that they use graphics as teaching tools in university courses. The USDA researchers are comparing our model outputs to other indicators of water stress. And we've heard about folks comparing local models to our national context information to try to provide context in the Central Plains. But what are you doing with these data? We are really interested in hearing about case studies related to decision making, cool analysis that you're doing, tool development. And so we'd love to hear, as you all explore, we'd love to hear about what you're finding. Next slide. And with that, I'm going to lead us to close. But I'll say, if you want to tell us about what you're finding out, the nwdc@usgs.gov is a great email address for us if you'd like to message us and tell us about any case studies or cool findings for your region. If you're interested in helping us with user testing, we're always trying to improve and iterate on our tools and our website. So the QR code is a great way. If you'd like to help us out, you can use that and sign up and be one of our testers, and we very much appreciate that. And yeah, and so at this point, I'm going to pass it back to Julia. I think we have a few minutes for questions, but really appreciate your attention and taking the time to hear about our new delivery system. Thank you very much.
Thank you so much. Huge thanks to Jennifer and Shirley for taking the time to join us today. And props to Shirley for a live demo. That can always be a bit nerve-wracking. So you did great. Okay, first question we have. Do we have estimates for when aquatic ecosystems sector data would be available?
Great question. There's a lot that's in process right now, but I think they're working on even coupling some of the aquatic ecosystem work and integrating with the water quantity models. So I think we're really looking more at the 2027 timeframe, but we don't have an established set timeframe for delivery yet.
Great, thanks. All right. All right. Next question. Just curious, why is the data limited to 2020?
I'm happy to take that one. So this data is a companion to the National Integrated Water Availability Assessment Report, and that focused on the time period from 2010 to 2020 to look at the variability and kind of the status of water supply and use and quality in that time period. And then future reports will focus on adding updating those data to more current years. And then those updated results will be subsequently added to the data companion as well. So some of it was tied to the report and how much time it takes to prepare the report and then prepare the data companion. But we will plan updates in the future as they become available, I think.
Thanks. All right. This question is also kind of thinking, zooming out, adding more. Uh, Zayed asks, I was wondering if you have any plans to include topographic data sets like DEMs to the platform, or if the focus will remain solely on water availability products. And then they provide a link for where they typically download DEMs.
That's a good question. There's so much that you could put in a platform like this. And what we've been aiming to do is really have that laser focus around water availability, just to keep it as a cohesive product. So I think we'll leave the DEMs to the national map folks and hope that, good collaboration can happen there.
Julia, I'm so sorry. I accidentally clicked answered on somebody's question when I was trying to type a response. So that person asked about how you can, if you wanted the data across the entire state, to use the data file directory to download data for that, but how do you extract only your state? And so I answered by putting a link to a tutorial where we show how to do that.
Perfect. Thank you so much. All right. Well, there's no more questions coming in at the moment, but we can hang on here for just a second if some folks are typing. So in the meantime, just a broad, maybe fun question. As you've been doing these demos and reaching out to the community with this product, has anyone come back to you with a surprising use where they're using this data in a way that wasn't really expected, but is an interesting application?
Not yet, but we would love if one of you guys had that and reached out to us about it. We are planning to do a lot more outreach and marketing kind of things this coming year. So hope maybe we'll naturally run into that as well as we go.
Great. All right. Well, seeing no more questions, I think we can wrap it up here. Again, thank you so much to everyone for joining us today. Oh, all right. Would the subset and download help with grabbing question?
It definitely would. So you can go, if you go to the subset and download page, you can see that a state is one of the spatial extents that you can get. And it works really well when you have smaller states, like very fast. But if you're trying to get, say, Texas or larger states like that, that's when we really recommend going to the data file directory to getting that instead. It's not that it won't work, it will, but it will just be slow and you'll have to get multiple files in order to be able to have all of that data.
All right, thanks. And one last question. Is groundwater availability indexed using GRACE data or some other metric incorporated in this in some way.
So, oh, Shirley, were you gonna hop on for that?
No, I was just gonna ask Galen if he would answer that.
Yeah, for sure. Um, in the first version of this report, which is associated with this release of the data companion, we didn't use GRACE data at all. We relied on groundwater well data, and that is not part of the data companion because the data companion focuses on releasing modeled data. Um, the next versions of the report are we have looked at incorporating GRACE and joining that with well observations to look at expanding our well network and understanding changes that we can see through GRACE and through changes in water level. And I think we're still kind of deciding how that data might be released. So that's kind of the status of using GRACE for these reports.
Perfect. Thanks so much. All right. And with that, we're over time. So thank you everyone for joining and for joining other quasi webinars this year. If you have a good rest of your 2025 and have a good one. Thanks so much.
Thanks so much, everyone.
Thanks. Bye-bye.
Thank you.